Hey guys, Mr. Mice is back here with you. This time we're looking at some basic trigonometry. So I know this is calculus, but we're going to review some trigonometry because we're going to need to do some calculus with trigonometry. So here's just a basic review. It's going to be really quick. I'm going to go through a lot of things pretty fast. So if you need to, you can slow me down, stop me, rewind me. You might need to go get a unit circle because I will not be going over the unit circle, but I do have a video on my YouTube channel on learning and memorizing the unit circle, but I will be using a unit circle in this video. So here we go. Let's get at it. So here are the basic trig that you'll need to know. You'll need to know sine, cosine, tangent, cosecant, secant, and cotangent. So I'm going to assume for most of you that this is review because you've done pre-calculus. So this is just kind of getting you back in shape with this stuff so that you're ready to go when we are covering it in calculus. So let's take a look at using a triangle here. So I'm going to use this right triangle to find each of these. So the sine is the opposite over hypotenuse. So the opposite, this is angle theta. Remember, you got to notice where theta is so that you can reference that one while you're doing these. So sine of theta is going to be the opposite over the hypotenuse, so that's going to be 4/5. Cosine is the adjacent over the hypotenuse, that's 3/5. Tangent is the opposite over the adjacent, which is 3/4. And secant is the reciprocal of cosine, so this is going to be 5/3. And that's pretty much it, all right? So that's it to using a triangle. Let's take a look at some more. So you have to know that trig functions are defined as circular functions. So we're looking at, this is an initial side here. And as we go counterclockwise in our xy axis, and we stop at a terminal side, the angle theta is right here. And we can find a right triangle to find this value, this point, x, y, using trig. We can use these, in calculus, we like to use these angles as radians. So we are going to be using radians and not degrees in calculus. Well, more often, sometimes we'll use degrees, but most of the time, if not all the time, we're going to be using radians. So make sure you understand radians and how they are related to the unit circle. So we can use circular function for trig like this. And again, we're just using x and y instead of adjacent and opposite, and r instead of hypothesis. That's the other class. That's statistics. Instead of hypotenuse. All right. So just remember these. You'll need to know them. And, you know, actually, if you just remember also the SOHCAHTOA stuff, you can pretty much figure these guys out just by SOHCAHTOA. Okay? All right. So let's take a look at some examples of this. Find sine theta, cosecant theta, and cotangent theta if the angle theta is in standard position. All right, so we're going to go ahead and plot -5, 1, 2, 3, 4, 5, and +2. There's my point. Make a ray over there. Did I move into the screen, guys? I don't know. Moving myself around. Okay. So we're looking at basically this right triangle here. This is -5. This is 2. All right. This is my reference angle right here, right there. And this is going to be 5 squared plus 2 squared, and the square root of that is going to be square root of 29. Okay, and I get that by doing r equals the square root, like I said, 5 squared plus 2 squared. Now, I don't need to worry about the negative because when I square the negative, it's -5 times -5, which is positive. Okay, so the sine of theta. Now, this is going to be the same as the opposite over the hypotenuse, 2 over root 29. So this angle here, theta, I'll call it theta 1. This is theta. These are called coterminal angles. So I can use them the same way I do the other ones. So cosecant of theta. Cosecant is the reciprocal of sine. And cotangent is the reciprocal of tangent. Tangent would have been opposite over adjacent, 2/5. So I'm going to get -5/2. Now I do have to put the negative in there because I am in the second quadrant and I do have -5. All right. Okay, let's take a look at some other ones here. We use reference angles in the triangles. Really not much different than the right triangle trigonometry. So some reference angles are 30, 60, 90, 45, 45, 90, 30, 45s. So just if you know, for remembering things, here is so let's say I have a 60. It's an equilateral triangle, all right? 90. This is going to be 2. This is going to be 1. It's going to be √3. All right, or if I have a 30, 60, 90 right triangle, okay, the one opposite the 60 is √3, the one opposite the 30 is 1, and then this is going to be 2. For 45, 45, the sides are both 1, and then your hypotenuse, your hypotenuse is √2. So let's take a look at using reference angles. Draw the angles in standard position and make a reference triangle. So 210 degrees, all right, 210 degrees is going to be all the way over here, right? That's 210 degrees. So I'm going to have, like this. Okay. Now, cosine of 210 degrees. So 210 degrees, this is 180. So what's left over from 180? That's going to be 30. This is 60. All right. So if this is -√3, this is going to be -1, and this is going to be 2, right? So my cosine of 210 is going to be the opposite, which is, adjacent. Gosh, come on, pen. Adjacent over hypotenuse. Adjacent over hypotenuse. SOHCAHTOA. All right, let's take a look at tangent. All right, so 315 is going to go all the way over here. Now 315 leaves what left over? That's 45. So that's going to be 1, -1 in √2. And so tangent is opposite over adjacent, so I'm just going to have -1. Now, again, if you've learned your unit circle really, really well, you probably don't need the reference triangle because you can just use the unit circle for those types of problems. So let's take a look at just converting really quickly, converting from radians to degrees. What we're going to do here for radians to degrees is we're just going to, we can either use the unit circle or multiply by 180 over pi. That's going to give me 90 degrees. We know pi over 4 from the, what was that? We know pi over 4 from the unit circle is 45 degrees. Wow, my OneNote just does not want to let me do this. 45 degrees. We know pi over 3, again from the unit circle, 60 degrees. And pi over 6 is 30 degrees. Okay, so we can convert these common ones. And again, I really think the best thing to do here is to understand and use your unit circle. So if you don't have a unit circle handy, go copy one down. 5 pi over 4 to convert from radians to degrees. We're going to take and multiply by 180 over pi. Okay. Okay, so that's going to cancel that, and that's going to give me 225. Or another way to do it is to do this. 5 times pi over 4, right? Which is 5 times 45. We already know that. 270. Okay, 270 is 3 times 90 degrees. So 3 times 90 degrees is pi over 2. So that's 3 pi over 2. That's easy enough. Okay, negative 120 is negative 2 times 60 degrees. We knew 60 degrees was pi over 3. So this is negative 2 pi over 3. Easy enough, right? Okay, so that's converting. Let's take a look at some other stuff we've got to be able to do. Draw angles in standard position and make reference triangles to figure out the following without a calculator. So again, you can do this using reference triangles, or you can do it using a unit circle. I'm going to keep coming back to that unit circle because I think it's actually easier to do unit circle than reference triangles. But that's my opinion. All right, 5 pi over 6 is going to be about 150 degrees, so that's over here. And that's going to give me a 30, 60, 90 triangle, so I'm going to have root 3, negative 1, and positive 2. So the tangent is going to be the opposite over adjacent, so negative 1 over negative 1/3. Negative 3/4, that goes this way. Okay, a negative angle actually goes backwards. It goes clockwise. And you're going to have, this is a 45, 45. So the cosine of that is going to be negative 1 over root 2 because it's the adjacent over hypotenuse. And then 5 pi over 3 is going to be about 300 degrees. It's over there. That's going to give me another 30, 60, 90 triangle. This time with the 60 right there. And that's a negative 3 because negative root 3 because it goes down. And the cosecant is going to be, remember, it's the reciprocal of sine, so it's 2 over negative root 3. All right, let's take a look at ones really using the unit circle. So make sure that you have your unit circle written out somewhere and you really have memorized that, because memorizing your unit circle is key to getting these things done and getting them done correctly and getting them done quickly. All right, so sine of pi over 6. So you're just going to go over to pi over 6. Sine, again, is going to be your y coordinate in your unit circle. So sine of pi over 6 is going to be 1/2. So you're just looking at your y coordinates for sine, and you're looking for your x coordinates for cosine. So sine of 0 is going to be 0. Cosine of 0 is going to be 1. Again, cosine of 0, 0 is your radian. So this is 1 comma 0 right there, right? 0 comma 1, negative 1 comma 0, 0 comma negative 1. And remember, your y value is going to be your sine. Your x value is going to be your cosine. Sine of pi over 2 is going to be 1. Cosine of pi over 2, 0. Sine of pi, 0. Again, you can probably be doing these as I go along here. Now, tangent is sine over cosine. That's going to be 0. So y over x. Sine of 3 pi over 2 is negative 1. Okay, that's right there. Cosine of 3 pi over 2 is 0. Cosine of negative pi. Now, negative pi actually goes this way. Okay, negative pi is the same as pi. So I'm going to have negative 1. Tangent of negative pi over 2. Now, negative pi over 2 goes this way. Okay, so negative pi over 2 is right here. And tangent of negative pi over 2 is going to be, remember, it's sine over cosine. Well, sine over cosine gives me negative 1 over 0. So we're going to just say this is undefined. All right, we can't have it over 0. Okay, so remember, you need to remember these rules for cotangent, tangent, cosecant, and secant. These are called the reciprocal rules, and you'll need to be able to use those reciprocal rules and understand these reciprocal identities. There aren't a lot of identities that you're going to need to know on the AP exam, but these are some of the important ones. Okay. So if sine theta equals 3/5, find the possible values for each of these. So anytime you've got a problem where you've got a trig equal to a ratio here, you're going to most likely you're going to create a triangle. So the triangle is going to be, there's a few things you can do. The sine is 3/5. So sine is the opposite over hypotenuse. So you can have something like this, or it could also go on this side, right? Because this is also 3, and it would be negative 4 and 5. Each of those would work. So cosecant here is going to be 1 over sine. It's reciprocal, so that's 5/3. Doesn't matter which side it's going to be on. It's still going to be 5/3. Cosine, however, does depend on which side because it's the adjacent over hypothesis. So we're going to say plus or minus 4/5. We don't actually know. And this one also is going to be plus or minus, and it's going to be the opposite over adjacent. Again, we don't know if it's going to be on the right side or the left side of the y-axis. Now, when we solve trig equations, we're going to need to work backwards, and we're going to have to figure out what is going to give us, like what angle in the unit circle will give us this is our answer. Now what -2 over root 3, if I divide the top and the bottom by 2, I'm going to get -1 over root 3 over 2. Or I can have 1 over, well, that's the only way I'm going to write it. So let's just do that. Okay, it's going to be 1 over -root 3 over 2. Now what I did, the reason I did that, I divided the top and the bottom by 2, is because I know that cosecant is 1 over sine. And I know that, that sine is the y value in my unit circle. And so this is, really, it's 1 over this y value. And so really all I have to do is find any y value that's -root 3 over 2 in my unit circle. So y values that are -root 3 over 2 are going to be right here and right here. And those on the unit circle are at 4 pi over 3 and 5 pi over 3. All right, so sometimes you got with cosecant, secant, tangent, and cotangent, you got to kind of finagle what you're kind of looking for. So let me give you another example here. Cotangent, I know, is cosine over sine, right? So what I really want is, since I have a root 3, I really want that to look like this. Root 3 over 2 over 1/2, right? Because then these guys will cancel out, and I'll have root 3. And the reason I want to do that is because I know that in the unit circle, I have root 3 over 2 and 1/2 as my coordinates. Cosine is x, sine is y. So really I'm looking for this to be x, this to be y, or I can alternatively have these both be negative for x and y. Okay, so where is that on the unit circle? Root 3 over 2 and 1/2 is going to be right here. Okay, at pi over 6. And -root 3, -1/2 is going to be over here at 7 pi over 6. So theta equals pi over 6 or 7 pi over 6. Okay, so that's how you do those. All right, let's take a look at one more here. Now, we've got cosine squared theta, so what we're going to do is we're going to solve for that first. So cosine squared theta equals 1/2. And we're going to have cosine theta equals plus or minus root 2 over 2. Now, where does that happen? Where is the x value? Remember, that's the x value. Where is that root 2 over 2? If you looked on a unit circle, that's at all the pi over 4 values. So we're going to say theta is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right? Okay. So make sure you are good with your signs. Okay, it's very important that you're good with your signs. And get it? Signs. S-I-N-E and S-I-G-N-S. But this is basically just a bunch of trig that you're going to have to remember from pre-calc. Here we go, guys. Later.